Okay, the 10.2 quick check. First off, we're asked to take two atoms and draw their Lewis dot structures for the particular atoms, and then decide what kind of bond it is and draw the Lewis structure for the molecule. So we start with Na and Cl, and we go, okay, that's easy. That's a metal and that's a nonmetal. So we know that this is going to end up being ionic. Okay, we have metal and a nonmetal. Sodium is in column 1, so it's going to have 1 dot. Okay, chlorine is in column 7, so it's going to have 7 dots. Okay, and now what really happens is that when those get together, because it's a metal and a nonmetal, the electron from the sodium is going to be shifted over to the chloride because the chloride has much higher electronegativity. So we're going to end up with a sodium, which is going to be an ion because it lost its electron, and we're going to have a chloride that's going to also be an ion because it gained 1 electron, and the glue that's going to hold those together is the fact that one's positive and one's negative, and they're going to attract each other. So that's the first part. Then we get to H and Cl. Well, H and Cl, okay, H is, just a single atom. A single electron. It's in column 1. Okay, and again, Cl exactly the same. It's going to have 7. Okay, what's going to happen when these two get together is that they're both nonmetals. So we're going to stop and look at, okay, what about our strong nonmetals? Okay, chlorine is one of those strong nonmetals, but hydrogen's not. Hydrogen, we're going to say, is a weak nonmetal. So they're going to share, but they're not going to share equally. So what we're going to get out of this is a covalent bond. But because they're not going to share equally, that's going to be a polar covalent bond. So how are we going to draw that? We're going to say H, okay, is going to share the pair of electrons with chlorine, and then there are 3 lone pairs on the chlorine. So, a chlorine has an octet. Now we might also want to say, okay, this guy is going to be a little bit negative. This is going to have a partial positive charge. Okay, so I'm not sure whether, if we would say just do the Lewis structure for the compound, I wouldn't put in the plus and minus, but, it doesn't hurt to put them in just to show that that's what's happening. Okay, second question is talking about Lewis dot structures. Okay, so carbon and chlorine, hopefully we're getting pretty good at this. So you say, well, carbon, we know it can make 4 bonds. Okay, chlorine, because it has 7, it can make 1 bond. So we know that bonds are going to occur where there is a single electron. So these two are going to make a bond. I'm going to put a line. Okay, same thing for here's a chlorine. It's going to have 7, and that's going to make a bond. Okay, chlorine's going to have 7. It's going to make a bond. And chlorine has 7, and it's going to make a bond. And that is our Lewis structure right there. Okay, remember we can use lines, we can use dots, we can use combinations of lines and dots. And this is our Lewis structure. Okay, next one over here, nitrogen. Okay, nitrogen, we should remember it has 5. It's in column 5, so it has 5 dots, 1, 2, 3, 4, 5. That means it has 3 half-filled orbitals, 3 single electrons, so it can make 3 bonds. Chlorine, again, we know chlorine has 7, so it can make 1 bond, so it can make 1 here. Chlorine, 1, 2, 3, 4, 5, 6, 7, it can make 1 bond. And chlorine, 1, 2, 3, 4, 5, 6, 7, it can make 1 bond. And there is our structure. Okay, again, I'm using lines for the 3 bonds, and there's a lone pair on the nitrogen. Okay, OCl2. Okay, oxygen. Okay, let's get a different color. Okay, oxygen has 6 valence electrons. That means it has 2 places where it can make bonds. So when we had our model kits, then the red spheres were the oxygen atoms, and they had 2 holes drilled in them. And those 2 holes were not on opposite sides. They were kind of next to each other, like we have here. Those 2 bonds, look like line 90 degrees. Okay, again, chlorine we know has 7 dots. It can make 1 bond. I'll put that in. And another chlorine, 1, 2, 3, 4, 5, 6, 7. That can make a bond. So here's our molecule. Okay, it's a little bit off-center. It's okay. So oxygen making 2 bonds to chlorines. Okay, FCl. Okay, F is from family 7. So it has 7 electrons. It can make 1 bond. Chlorine has 7 electrons. It can make 1 bond. So they can make 1 bond between the 2 of them. Carbon dioxide. Now that one may take a little fancier. So carbon, okay, has 4. Let's get a different color. Okay, carbon can make 4 bonds. Okay, has 4 half-filled orbitals. and then 4 single electrons. Each oxygen can make 2, and if I draw it like that, it makes it pretty obvious that those 2 can pair and those 2 can pair. And I'll put another oxygen here, and those can pair up and those can pair up. So when we kind of clean up our picture, we'd say carbon makes 2 bonds this way to an oxygen, and it makes 2 bonds this way to another oxygen, and that could be a way we draw our molecules. CH2O. Okay, one of the things to remember is that hydrogens always have to be on the outside. So let's start with our carbon, and carbon can make 4 bonds, has 4 dots. Okay, a hydrogen can make 1 bond. Let's put it here, and let's make a hydrogen here. Okay, that can make a bond. So there's 2 bonds. And then what happens is we have 2 bonds left, and we have an oxygen, and we know that oxygen can make 2 bonds. So not too surprising if we say let's make the bond a double bond between the carbon and the oxygen. If I try to clean that up a little bit, I'll put carbon double bonded to an oxygen. Don't forget the 2 lone pairs on the oxygen. And we can get a hydrogen making a bond, a hydrogen making a bond. It will look something like that. Okay, down here, we say, well, carbons and hydrogens, we know the hydrogens have to be on the outside. Hydrogens can only make 1 bond, so they have to go on the outside. So I'm going to get hydrogen, I'm going to put a carbon, I'm going to put a carbon, and I'm going to put a hydrogen. Okay, hydrogens can make 1 bond because it has 1 dot, but each of the carbons, okay, has 4 single electrons. They can make that. So we know we're going to have to connect our carbons and hydrogens, and we're going to have to connect our carbons together. And if we notice, we say, well, we have a place here where those can share and those can share. So we're going to end up making a carbon-carbon triple bond and then a single bond to the hydrogens. So in this case, our structural formula also counts as our Lewis dot formula. Or again, we could draw this whole thing with dots. So we can use dots, we can use lines, we can use combinations of dots and lines. Okay, for nitrogen, let's change colors for variety. Okay, nitrogen has 5 electrons. And here's nitrogen, we'll give it 5 electrons. And we know that the hydrogens have to be on the outside. So we can see that I can connect the nitrogen and the hydrogen, the nitrogen and the hydrogen. And obviously the 2 nitrogens are going to need to connect. And we still have a pair of electrons, we can connect those. So we can see what we're going to get is we're going to get a nitrogen-nitrogen double bond. Okay, bonded to a hydrogen, bonded to a hydrogen. And what we have left over, we have a pair of electrons and a pair of electrons on our nitrogens. So that would be a nice cleaned up version of our picture. Okay, and the last one here, okay, HOOH. Okay, again, the hydrogens are going to have to be on the outside. Now the oxygens have 6 electrons. Okay, now this is going to be a little bit tricky here. So I know I'm going to connect my hydrogen to my oxygen, and I'll connect my hydrogen to my oxygen, and I'm going to have to connect those 2 oxygens together. So if I want to clean that up, I would make a single bond between my oxygens, okay, bond to my hydrogen, bond to my hydrogen, and then I have 2 lone pairs on each oxygen, and that would be one way of drawing that picture. Okay, another way would be maybe to show it like a hydrogen bonded to an oxygen, bonded to an oxygen, bonded to a hydrogen. Might be something like that. Sort of a bent molecule. Okay, so a little messy looking, but you know, this is a couple of ways to show peroxide. Now the last question on here says to go back and take these pictures and see if you can identify which of those compounds down below are represented by these pictures. Now it turns out that I just know that these pictures actually are related to the top 6 up here. So we're looking for a molecule that has a central atom and 4 atoms. That's this guy here. So this would be CH4. I'm sorry, CCl4. Okay, and here we have an atom and an atom for FCl, and here we have an atom and an atom. So this one would be the FCl. Okay, looking down below, here I've got 3 atoms connected to 1 atom in the middle, and I've got a lone pair. That would be this guy here, NCl, 3. And we're not showing the lone pairs on these outer atoms. Okay, that's just not what we're showing, but That would be the basic shape. And the CO2, central atom with two atoms sticking out, and notice that these would be at 120 degrees. And that's going to be important when we talk about whether a molecule is polar or not. Okay, over here I have OCl2. I have a single atom with two atoms coming off. And because of the lone pairs, okay, they have to come off at an angle. So this is here OCl2. And my other picture is CH2O, C in the middle with an O and an H and an H all coming off. So that would actually look like this guy. Okay, CH2O. So these lines, these bonds we're showing, we're not making a distinction whether that's a single bond or a double bond. And we're not showing all the lone pairs on the outside atoms. But you can see that that's how these would relate to these pictures down below. And that's the quick check.